Welcome to Boots on the Ground Grazing, training tools for forage success. Grazing management is where soil biology, plant physiology, and animal behavior converge, right here in the pasture, under your boots. Every step you take connects you to living, breathing systems. The microscopic communities cycling nutrients in the soil, forage plants growing and recovering through distinct growth stages, and livestock making choices based on nutritional needs, palatability, and availability. The complexity is what makes this work challenging and fascinating and rewarding. Our job is to develop the skills and tools to read the systems accurately and respond with informed, adaptive decisions that balance animal performance, plant health, and soil resilience. Today, we'll focus on practical, hands-on tools designed specifically for the field. These tools are more than measurements, they're the language of the land. They help us move conversations from opinions and assumptions to grounded observations and evidence. Because grazing management is dynamic and site-specific, it changes season by season, pasture by pasture, herd by herd, and it demands adaptive thinking. Adjusting stocking density as forage availability fluctuates, altering forage duration and grazing duration to protect regrowth, or changing grazing sequences to encouraging desired plant species. It's a constant balance between livestock needs, plant recovery, soil processes, and the ever-changing weather. But it all starts with curiosity and connection, helping producers not just hear facts, but see and feel the story their land is telling. Sometimes that story is a soil sample alive with earthworms, or in the new shoots pushing through the grass after a well-timed rest period, or in the shape and texture of a manure patty, signaling digestion efficiency. When producers engage with their land through observation and simple tools, they gain confidence to make decisions tailored to their unique systems. My goal today is to show you some demonstrations that bridge complex science with real-world practicality. Tools that help translate technical concepts like plant physiology, soil microbiology, and animal nutrition into clear, actionable insights. And tools that spark better questions. How tall is the forage? Is the soil compacted? Are the animals grazing evenly? What's the condition of the plants post-grazing? With this approach, you're not just managing pastures, you're partnering with ecosystems. And from that partnership comes resilience. Small shifts, moving a polywire to rest a paddock, delaying a grazing pass to let roots rebound, adjusting stocking rates based on forage growth, that all ripples outward, strengthening the entire system. That's where change happens. Not always in reports or regulations, but in the quiet decisions made day by day, acre by acre, by the people who know their land and livestock intimately. So let's take that next step together. Walk the pasture, ask the questions, use the tools, and deepen our understanding of what the land needs to thrive. Because successful grazing is never static. It's a living, evolving conversation between soils, plants, animals, and the people guiding them. Okay, so the first demonstration that I like to do to start field days or in the classroom is the apple as the earth demonstration. I believe this demonstration really puts things into perspective. I first saw this demo when I started grad school, and as simple as it is, I feel like it really stuck with me and just truly shows why we're talking about the things that we're talking about today and why pasture management matters. Okay, so I want you to think of this apple as our earth. And if we think of this apple as our earth is huge. That seems like a lot of land to grow everything we need to feed our growing population. But that's not realistic, right? This whole apple, the whole earth, is not land that's available to grow food, fiber, and resources. So, my first question for you is how much of the land, or how much of earth, I should say, is covered in water? If you said 75% or 3/4, you would be right. So the first thing we're going to do is take our apple and cut it into quarters. So our earth is now in quarters. We said 75% or 3/4 of that is water. So we can't use this to grow anything that we need or use for agriculture. So we get rid of that. That goes to the side. And we're left with 1/4 of the earth. So 1/4 of the earth being land. Still a decent size. But how about land that's too hot, too cold, too dry, too wet to grow food on? We're going to take this 1/4 and cut it in half and get rid of a half of it. So what's remaining is about 1/8 of what we started with. This is a math lesson as well. So 1/8. But on this land that's not too hot, too dry, too cold, too wet, all the things, we need our cities. We need our grocery stores. We need our houses, our towns, everything that we need to survive. So that's going to take a lot of land out of agriculture as well. So now we're going to cut this apple again into quarters and get rid of 3/4 of that. So 3/4 of that land, we're living on. We're going to the grocery store at. We're going to school. So we're left with about 1/32 of what we originally started with. But we have to do one more thing. I have just peeled the skin off the best I can of that 1/32 of apple. This is what's left. This piece of skin is all of the topsoil that we have across the world to grow everything we need to survive and thrive. So this just really puts into perspective why we need to be land stewards and put our conservation foot forward. So the health of this topsoil is going to drive everything else. The roots that grow down into it, anchoring plants and cycling nutrients, the billions of microbes, fungi, and tiny creatures living in it, the unseen workforce that drives nutrient availability and soil structure, the water it holds, filtering rain and supplying nutrients and moisture in dry times, the nutrient cycling and complex webs feeding plants and animals alike. And here's something many people don't realize. Most of this precious topsoil is quite literally under your boots when you walk pasture. What you do with this skin, how you manage grazing, rest cover, and disturbance, that's what builds or breaks the entire system. So when you're working with producers, it's not just about counting cows and checking fences. It's about protecting this skin, the living surface, and everything that depends on it. Because no matter how many animals you run or how good your genetics are, if the soil isn't healthy, nothing else will reach its full potential. And that's why grazing management isn't just about livestock. It's about the soil, plant, animal relationship as a whole. By midsummer, cool season grasses hit a wall and growth slows. Forage quality drops, and before you know it, you're feeding hay in July. Welcome to the summer slump. But here's the thing, it doesn't have to be that way. Enter native warm season grasses, the true workhorses of the summer grazing season. Some of the most valuable species include big bluestem, Indian grass, switchgrass, and eastern gamma grass. While your tall fescue and orchard grass are sweating it out, these species are just getting started. They thrive in heat, push through drought, and continue producing high-quality forage when other grasses shut down. And it's not just about what's above ground. These native grasses send roots 6 to 10 feet deep, tapping into soil moisture that cool season grasses can't reach. That deep rooting means exceptional drought tolerance, improved water infiltration, greater carbon sequestration, and long-term soil structure stability. They don't just fill the gap, they transform the summer forage landscape. Warm season grasses also produce high biomass and can maintain excellent forage quality when grazed at the right stage. Livestock perform well on them, especially when paired with good rotation and mineral supplementation. Now, let's talk establishment, because that's what usually scares people away from native warm season grasses. While the payoff is big, the process takes patience. Establishing native warm season grasses isn't like drilling a ryegrass and seeing green in a few weeks. You're investing in a system that can last 15 to 20 years or more. But it might take 2 or more growing seasons before you see full potential and production. Some years may require reseeding or spot touch-ups, and that's normal. Don't let that scare you. These grasses start slow, but they're strong to stay. Want the best advice? Talk to someone local who's done it. Ask what worked, what didn't, how did they manage weed pressure, what seeding rate gave them a strong stand, how did they time their planting with spring rain or soil temperatures. A little local knowledge can go a really long way. But no matter what you do, I can't stress this enough, don't skip the most important step. Rule number 1, eliminate competition. Cool season grasses and weeds will outcompete your warm season seedlings if they're not controlled before planting. But you've got options. Use cover crops to prep the site and suppress weeds. Use tillage to create a clean, firm seed bed. Use herbicide burn downs to reduce competition from fescue, annual grasses, or broadleaves. Whatever method you choose, just make sure your seedlings aren't fighting for space and sunlight in those first critical weeks. Success starts with a clean seedbed and a clear strategy. Native warm season grasses may not be instant gratification, but they are long-term insurance. They give you summer forage, grazing flexibility, and a way to keep your animals on pasture, not on hay, during the hottest, driest part of the year. With warm season perennials in your system, you're not just avoiding the summer slump, you're building a pasture program that performs 12 months out of the year. Let's talk about common mistakes when establishing. The first, of course, is skipping step 1. That biggest error is not properly eliminating existing vegetation before planting. Warm season grasses, as we said, are slow and weak early on, and cool season grasses will outcompete them if left unchecked. Take the time to kill off old sod, use burn down herbicides, or employ tillage to create a clean, firm seed bed. I know it sounds repetitive, but I can't say it enough. Using low quality seed or wrong varieties is another common mistake. Make sure to buy certified seed from a reputable source. Some seed mixes labeled native have a lot of weed seeds or less adapted varieties. Choose varieties suited for your region and your soil type, and be wary of overly cheap seed that's going to cost you more in the long run. So yes, weed management before, but it doesn't stop there. Ignoring weed management after planting is a big mistake. Native warm season grasses need to be protected during establishment, which often means follow-up weed control. Don't assume planting the seed is the last step. Monitor your fields, and if weeds start to take over, use spot treatments or plan grazing to reduce competition. But there's that word grazing. Overgrazing too soon is a big mistake. Warm season grasses need time to build their root reserves, and grazing or mowing too aggressively in the first year will set them back. Let plants grow to at least 18 inches before the first grazing, and always leave enough residual for regrowth. So where we just came from was a native warm season grass variety trial. But now we really get to see the native warm season grasses in action. So what we saw back at the variety trial was very mature stands. This is what you're going to see when you're grazing. And the important thing to remember is really our difference between our native warm season grasses and our cool season grasses. And we can see that contrast right here. So our cool season grasses, we can see during these summer hot months, the amount of biomass that's present compared to our native warm season grasses, our workhorses of the summer. So these native warm season grasses are able to keep growing during these hot summer months. It's also important to remember the amount of residual you're leaving for these native warm season grasses. Get yourself a grazing stick. It's a very effective but simple tool. With our cool season grasses, they can handle about tall fescue going down to about 2 inches, orchard grass 3 to 4. But when it comes to our natives, we want to leave, about 8 to 10 inches residual to keep growing a healthy stand. We mentioned rotation earlier. Let's unpack that a little bit more. If we were to look down there where the cattle are grazing, that's going to be the same soil, same rainfall, same forage species compared to the paddock that I'm standing in right now. But there is going to be a contrast. Down there, you've got continuous grazing. That's going to be short, uneven patches, plants graze to the ground and struggling to recover. Animals go back for the best bites again and again, and over time, the weaker species drop out. The pasture loses diversity and resilience. On the other side, we've got rotational grazing. Uniform growth, deep green color, and better overall coverage. The big difference is rest. Rotational grazing isn't complicated. It's not about building fancy fences and moving animals every hour on the hour. At its core, rotational grazing is about one thing, which is recovery. You're giving plants the time they need to regrow leaf area, rebuild energy reserves, and push roots deeper into the soil. That recovery is what drives productivity. It fuels photosynthesis and fuels soil biology and increases the stand's ability to resist drought, compete with weeds, and bounce back after stress. Think of leaves as factories. They capture sunlight and build the plant's structure. Leaves feed the roots, roots feed the leaves. If you were to graze every plant down to a nub, you shut down the factory. The whole system stalls. But if you leave enough leaf area behind, the plant can bounce back faster and stronger. So, what are the basics? Start grazing when forage reaches about 8 to 10 inches. That's when you've got a good canopy of leaf area and strong photosynthetic capacity. Stop grazing at 3 to 4 inches. That's the critical stubble height. Remember that grazing stick I showed you all earlier? Great tool. When you leave enough factory floor, you're able to kickstart regrowth immediately. Then rest again until it hits about 8 to 10 inches and return those animals. It's not about the calendar, it's about plant height. Cool season forages grow fast in spring and fall, but much slower in midsummer. So use your eyes and hands, not just dates on a planner, to make those decisions. Let's take a closer look at what soil health really means beneath our feet. Imagine a pasture grazed too intensely and too frequently, season after season. Plants don't get enough time to recover between grazing events. Livestock are trampling during wet conditions, and that's going to compact the soil, crushing pore space and disrupting structure. What's happening below the surface? The soil's physical architecture begins to break down. Organic matter declines because roots are stressed and microbial communities aren't thriving. Soil particles become densely packed, more like bricks than the crumbly, porous matrix plants depend on. When rain falls, instead of infiltrating and nourishing the root zone, water runs off or pools on the surface. Roots can't penetrate deeply, limiting the plant's access to moisture and nutrients during dry periods. Even more critically, microbial populations, the microscopic engines of nutrient cycling and soil aggregation, decline in diversity and activity. The entire soil food web unravels, and the resilience of the pasture ecosystem. This is a simple yet powerful field test called the slake test. So slaking is what happens when a soil aggregate starts to kind of fall apart. Water is rushing in those pores and air is being pushed out. So here we have a soil that's been pretty continuously trafficked. And here we have a soil that has been under pasture cover. So what we see is some slaking from both, but with even more time. Right now we can see our disturbed soil slaking a little bit more. We have more soil aggregates breaking apart and falling to the bottom. The healthy soil remains a little bit more intact, holding together like almost like a rich chocolate cake. Particles are bound together by organic matter and microbial secretions that are often called glues, the glues of the soil. Water will infiltrate better, carrying oxygen and nutrients into the root zone will be easier, where plants and microbes thrive. The degraded soil, on the other hand, is going to, more quickly disintegrate, clouding the water as silt and nutrients wash away. So this is going to be erosion happening in real time, loss of precious soil and carbon that undermines pasture productivity. Kind of a prime example is today. Sometimes they don't work out exactly how you plan with demonstrations. Talking with producers, talking with students, our continuous till maybe is not slaking as much as we'd like to see because of things like compaction and holding together. I will say with demonstrations, it may not always be perfect, but with some explanation as you show, it'll get the point across. That was a prime example. Now let's show it with a rainfall simulator. This isn't the perfect demonstration, but it'll get the point across. Tray 1 is going to be kind of our rested, covered paddock area, leaving some residual. Tray 2 is going to be overgrazed, bare, and compacted soil. So let's see what happens when we simulate a rainfall event. So our more rested, healthy tray is going to act like a sponge. It's going to slow and steady infiltration. The overgrazed bare soil tray is going to shed water almost instantly, fast runoff, and muddy water. Look at the jars or the containers underneath. For our more rested, we have a lot more water down there, and it's a lot more clear. Over here, we have kind of murky, sediment-filled runoff from the degraded one. That's topsoil, that's fertility, that's money, literally washing away. This is not just about soil health and forage growth, it's about resilience. Healthy soil holds water, feeds roots, and bounces back from stress. Overgrazed soil leaks water, nutrients, and opportunity. So next time you're walking a pasture, pause and ask, is there enough residual? Are the plants getting the rest they need? What story are the roots telling us beneath the soil? Use your tools, pull a plant, pour some water, run a grazing stick over the canopy. Because when a producer sees it, really sees it, they start asking new questions. And that's the spark. That's when change begins. So now we're going to keep kind of thinking about soil health and aggregate stability. This is a demonstration I like to do, and it works with all age groups, and it's really fun. We are going to make two types of cereal today. One with love and one with destruction. And this is going to represent our different soils. So here's our soil made with love, or our cereal made with love. The Cheerios are still intact. We have good structure. Now we're going to take the same amount of Cheerios and have that in a Ziploc bag. And we are going to pulverize it. you're asking somebody to do this demonstration for you, most times you gotta say, keep going, keep going. We want these Cheerios completely pulverized. Okay, may seem like overkill, but it's worth it once we see the demonstration. So here's our pulverized cereal. We will put that into a plastic cup. So now, instead of thinking of these as cereal, think of them like soil. This is going to be a well-structured soil. Think about when we pour our milk or our water over these two cereals, what's going to happen? This one represents, a very pulverized, no structure soil, probably a lot of disturbance, kind of like continuous tillage or in a pasture system, continuously grazing. So watch how the milk moves through our first soil, well structured. And compare that now to our unstructured soil. So in our unstructured soil, what we see is a lot of ponding and sitting on top compared to our well-structured soil where the milk or the water has been able to run through. There's space for water, there's space for air, and that means space for roots. Another fun thing to do is to do the taste test. And for the taste test, you can ask your volunteer, your chef, to take a taste of this cereal and this cereal. And it's surprising how bad this one really is. So same nutritional content, same amount of ingredients, it's the same cereal. The only thing we changed is the structure. So think about that in terms of soil and how that's in turn going to affect your forage growth. If I was a grass, I'd pick this one, not this one. So what do we need to do when we have to reach for a hay bale? Winter feeding is one of the largest expenses in livestock production. The cost of hay, plus fuel to haul it, and labor to deliver it day after day can really add up fast. But here's the thing, it doesn't have to be that way. Hay feeding doesn't have to be a loss. It can actually be smart and a smart investment if you use it strategically. That's where rotational bale grazing comes in. So the traditional way for winter hay feeding in Virginia is a sacrifice paddock. So in a sacrifice paddock, cattle are kept in one location throughout the winter and brought a new bale every few days. This can result in buildup of manure in one area, a lot of disturbance, runoff. Rotational bale grazing is the pre-placement of hay bales directly onto the pasture before winter hay feeding begins and allowing the cattle access to the bales at a controlled rate using strip grazing, so using polywire. So I mentioned earlier that that's what I did for my PhD research. So we are standing in a paddock right now where I completed my rotational bale grazing work. This is where one of my hay bales was placed 2 winters ago. And it actually took a little bit of time to find it. That's always the biggest concern from producers is the disturbance. So where that hay bale is going to be, the animals may be spending a few days in that area. We can have very wet and muddy winters. But here we are about 2 years later, and we've got, some fescue coming up in there and a good stand of some crabgrass, which the cows love. All right, now let's talk tools, not software, not fancy gadgets or subscription apps, just what fits in your pocket or your vest or behind the seat of your truck. The tools that ground you in real-time decisions, connect you to livestock, and bring clarity to the pasture. These are the tools that turn observation into action, the tools that spark conversation, the tools that help a producer see what you've been walking by every day. Let's start simple, the grazing stick. It's just wood or plastic, no batteries, but it might be the most powerful piece of equipment you carry. You can measure forage height, what's here right now. Estimate forage yield, how many animal days is this giving me? Train your eye. The more you use it, the faster you can judge density, uniformity, and cover just by sight alone. And here's a field hack. Mark your boot at 4 inches, either with paint or in the leather. That line tells you what to leave behind. It reinforces muscle memory. It's your walking residue gauge. Use the stick to show others what you're seeing. Make it a habit. How about clippers in a square frame? Now we're in forage science territory. Clip 1 foot square from a paddock. Bag it, weigh it fresh. If you've got access to a food dehydrator, scale, or just a microwave, you can estimate dry matter. Multiply that weight by 43,560 feet, and you're in pounds per acre. It's not exact, but it's repeatable. It builds confidence. Do it often enough, and you won't need the clippers every time. You'll start to feel it in your boots and see it in your animals. This one's easy to carry. How about an old coffee can and a small digital scale? Drop in your clippings, weigh them, then use simple math to estimate animal days per acre. This is a powerful hands-on demo when you're walking a pasture with producers. It turns green stuff into numbers. You can show them that what looks full might only feed the herd for a day or two, or that what looks grazed down still has value. It's not about perfect data, it's about informed decisions. You've seen the forage, you've looked at the soil, you've walked the pastures and scored the manure. Now it's time to take all that field level information and plug it into a bigger picture, the grazing calendar. Grab something simple, a whiteboard, a big notepad, maybe even a printed calendar. Don't overthink the format. What matters is the conversation. Start with these prompts. What's growing when? When do you typically start feeding hay or supplement? When do you usually run short or feel the pinch? Are there times when pasture quality crashes or regrowth slows down? What month tends to make or break your year? Now pull out the markers and color code it. Green for growth periods, when pasture is cranking and ready to graze. Yellow for stress windows, summer slump, drought, cold snaps, or recovery delays. And red for shortages, when you're feeding hay or risking overgrazing. Let that visual sink in. This isn't a theoretical rotation on a dry erase board in February. This is a reflection of what actually happens on the land over a full grazing year. And every operation is different. And more importantly, it's a tool for making change. Now start tweaking. Could we extend green zones by better timing our rest periods? Can we delay hay feeding by stockpiling tall fescue in the fall? Is there an opportunity to plug in warm season annuals like sorghum Sudan grass, millet, or brassicas to help with summer gaps? What about native warm season grasses for deep rooting and drought resilience? This kind of seasonal mapping helps producers shift from reactive to proactive. They start to see when to back off grazing pressure and build reserves, when to rotate faster or slower, when to move animals based on plant readiness, not just habit. And over time, these calendar conversations become management strategies. You're not just drawing lines or dates, you're helping someone read their land like a living calendar, one rooted in physiology, weather patterns, and livestock needs. Every acre has a rhythm. Let's help producers tune into it. Now, let's go there, the manure, that liquid gold. Because if you're not looking behind your livestock, you're missing half the story. This isn't about consistency, it's about intake, balance, and timing. Loose and runny, too much water, lush forage, or imbalance in protein and energy. Firm and stacked and dry, might be underfeeding or low digestibility. Flat, shiny pancakes, that's the sweet spot. Good fiber, balanced protein, and energy, and optimal intake. Maybe animals and cows aren't much different than humans after all. You can tell a lot by how grazing management is working just by what you step over. It's real-time feedback from the rumen. And don't overlook your knife or your hands. Split a stem, look inside, dig up a root crown. How deep, how branched, how alive. Smell the soil. Is it rich and earthy, or is it sour and metallic? Those are all signs. You're not just gathering samples, you're building a relationship with the land. Here's the thing, none of these tools require a lab coat, but they do require attention. They make things visible and they slow us down. They create moments where someone says, I never noticed that before. And that's where the learning happens. These tools don't just give you data, they help you tell the story of a pasture and train others to see it too. This is how we build better grazers. One stick, one scoop, one manure patty, one square at a time. Here's a secret many forget. Grazing isn't algebra. It's not just about numbers, formulas, or perfect rotations. It's about fence building, hands-on, sometimes messy and deeply personal. It's about working with real people, animals, plants, and soils, each with their own quirks and stories. Start every conversation with questions. Ask the producer, what are your goals? What's working well right now? What's challenging? And how do you define success in your land? Then walk the field with them, pull a plant, check the roots, look for earthworms, feel the soil moisture. Talk through options on the spot, real-time problem solving. Don't talk at folks, walk with them, because real change doesn't come from fact sheets or lectures. It comes from trust, shared discovery, and helping someone connect the dots. This mindset of curiosity, collaboration, and adaptability is the foundation of lasting grazing success. Let's bring it all together. Today we've talked through the tools that matter most out here in the field. An apple demonstration, a vivid reminder of how limited and precious our soil really is. Maybe it's the slake test or the Cheerios demonstration, showing how water behaves differently in healthy versus degraded soils. Think about how leaf area fuels regrowth and drives vital carbon flow underground. The rainfall simulator, demonstrating the critical role of rest and cover that plays in the soil and forage health. And practical toolkits like grazing sticks, scissors, coffee cans, manure charts, and knives, simple tools that open up big conversations. Mapping the grazing year, gaining clarity on real growth and stress patterns to make smarter, more adaptive decisions. Behavior-based teaching, walking fields, asking thoughtful questions, and building the trust that creates real change. What do you truly need to do this work well? Maybe a grazing stick, maybe a good question, but really it's a willingness to listen, because grazing isn't a formula, it's a habit, a mindset, a conversation between people, animals, plants, and soil. Thank you for walking alongside me today. Now go walk with someone else. Bring a stick and bring a smile. Let's make better grazing simple, one pasture walk at a time.
This virtual pasture walk is brought to you by the West Virginia Conservation Agency, funded through the NRCS Grazing Lands Conservation Initiative. For similar content, please visit grazingprofessionals.us.